Alright, so these are the advanced trigonometric identities. And how do you remember them? So sec starts with a S. It's not gonna be sine, obviously, it's gonna be 1 over cos in terms of cos. And then we have cosec theta. It starts with a C. It's not gonna be in terms of cos, it's gonna be in terms of sine. Yeah, that's right. And then we have cot theta. It ends with a T, and thus it's gonna be in terms of tan. Alright. So then moving on, sec theta is 1 over cos theta. Thus, it's gonna be 1 over adjacent over hypotenuse, which is gonna be hypotenuse over adjacent. Or let's call this the base. And then we have 1 over sine theta is cosec theta. So 1 is gonna be 1 over opposite over hypotenuse, which is sine. And this would give us, I have hypotenuse over the opposite. Let's call this the perpendicular. Then we have cot theta is equal to 1 over tan theta. 1 over tan theta is going to be perpendicular over base opposite over adjacent, which would be base over perpendicular for cot theta. And now, before you move on, cot, we have cot theta is also equals to cos theta over sin theta. This is also an identity derived from the fact that tan theta is equals to sin theta over cos theta. Then moving on, we have the graphs of advanced trigonometric functions. The first graph is of cosec, which is equals to 1 over sin x. So first of all, imagine the graph of sin. This is the graph of sin x. So first of all, we go to the point at 0. The point at 0 gives us sin x is equals to 0. And since cosec is equals to 1 over sin x, which is 0, it's gonna be infinity. Alright, so this is gonna be something like this for now, no point. And then we have sin x is equals to 1. 1 over 1 is 1 over 1 is equals to 1, and thus we have a point at 1 at 90. And moving on at 180, we have sin x is equals to 0. So 1 over 0 is gonna be infinity yet again. So since we have infinity, let's make a dotted line which represents an asymptote again. Then moving on yet again, we have at 270 we have sin x is equals to minus 1. So this is gonna be 1 over minus 1, which is equals to minus 1. So we have a point here. And then at 360 we have 1 over 0 yet again, which is gonna be infinity. 1 over 0 is infinity and 0 over 1 is 0, just to clarify. And then let's make an asymptote since we have an infinity at 360. So the graph of cosec would look something like this. We had infinity at 0, and this is an asymptote. We have an asymptote here too, and then here. This approaches infinity here, and this would look something like asymptote, and this should never meet again. It should never meet, but it should look like as if they are approaching each other. Then moving on to the graph of sec x. First of all, imagine the graph of cos x. I label this as cosec x and this as sec x. So At 0, we have we have the graph of cos x as at 1. Thus cos x is equals to 1. Thus 1 over 1 is gonna be 1. Thus we have a point at 1 here, and then 0. 1 over 0 is infinity. Thus we have an asymptote here at 90. Then moving on, we have a minus 1 here. 1 over minus 1 is a 1. Thus 1 over minus 1 is a minus 1. So we have a point here. And then we have 0 at 270 yet again. Thus we have a dotted line and asymptote that is yet again at 270. And then we have at 360 cos x is equals to 1. Thus 1 over 1 is 1. And then we can plot our final point here, which would be this. And thus our graph for sec x would look something like this. This line approaches infinity from both ends, and this line also approaches infinity. This is the graph between 0 and 360. Alright, and these two lines again will not touch the asymptote. Always make the asymptotes dot, I recommend. And then we have the graph of cot x. First of all, imagine the graph of tan x. And this is the graph of cot x which we are yet to make. So at 0, we have tan x is equals to 0. So this graph will be infinity at 0. And then, so how about we write down the points? And then we have 90. And 90 tan x is equals to infinity. So 1 over infinity is equals to 0. Because it will obviously be a very small value which will nearly be 0. So we have 90 degrees and a 0. Then we have a 0 at 180 degrees, which will give us infinity yet again. Then we have at 270 infinity. Thus at 270 we have a 0 since 1 over infinity is equals to 0. Finally we have a 360 degrees, and at 360 we have 0, thus infinity yet again. Since 1 over 0 is infinity, we'll make this very small. Wherever we have infinity, let's make a dotted line there. So first of all, we have an infinity at 0. Let's leave that and just remember that instead. Then we have an asymptote or infinity that are at 180 degrees and also at 360 degrees. Let's now plot these 2 points. So at 90 we have 0. At 270 we have 0. So the graph would look something like this. And then here the graph would look something like this, and so on. Again, this is a curve. All right. And then, so these were the graphs of advanced trigonometric functions. And then moving on, how would advanced trigonometric functions be used in a question? So let's say we have this. So whenever we have advanced trigonometric functions in a question, always convert them to basic trigonometric functions. And then cross multiplying would give us sine theta is equals to half. We will proceed to find the basic angle alpha, which is given by sine negative of half and alpha is equals to 30 degrees. You should also remember this from the table of trigonometric function. And then since this is positive and sine is positive only in the first and second quadrants, let's make the graph. The graph would look something like, just a second. So the grid always remains the same. We have a 0 here and a 180 here, 90 and a 270. Sine is positive in the first and second quadrants, ASTC, and a basic angle forms with the x-axis always. Then we have a theta here, so we'll write theta is equals to 30 degrees in the first quadrant and 180 minus 30 degrees in the second quadrant, and theta becomes equal, and theta is equals to 30 and 150 degrees. This is our answer. Then we have this. So in this case, the first step is to convert this to basic trigonometric functions. And we have this. We will cross multiply, and this would become cos 2 theta plus 30 is equals to 1/3. Now notice that we don't have a simple x or theta here. Thus we need to alter the range. This step is often a common mistake that it is neglected. So first of all, multiply everything by 2. 0 remains 0 and this becomes 720. Then add 30 to everything. This becomes a 30 and this becomes a 750. And then you can proceed and find alpha, which is cos inverse of 1/3. This is alpha. Once you found alpha, the next step should be plotting a graph of ASTC. This is what the graph would look like since cos is positive in the first and last quadrant, fourth quadrant that is. Then you proceed to find the final values of angles. Your final answer that is. So from 0 to 360, we have 370.53 and 360 minus 70.53, which would give you 289.5 degrees. And for the next two angles, just simply add 360. So I'll copy this, I'll paste this, I'll space in it out, I'll increase the space in between, and then just simply add 360 degrees. This, so we have 2 theta plus 30 is equals to 70.53 degrees, 289.5 degrees, or 30.53 degrees, and a 649.5 degrees. Subtract 30 on both sides from everything. So we have this. This becomes 259.5. This becomes 400.5. Let's work till one decimal place. This becomes 619.5. Now divide everything by 2 on the right hand side and the left. So we have theta is equals to 20.3, 129.80, 200.3, 309.8 degrees. Now before you end, again, always remember to alter the range if necessary, else you would only end up with two answers. Always alter the range and remember to compare your final answer with the given basic range so you know it's right. And just to confirm, you don't have to reject any value. So these were the advanced trigonometric functions, their graphs, and their questions. And this is Ace the Levels signing off.